All right, so this section is, there's really no good place to do this. We're going to be using the calculator a lot more towards the end of the year when we get to kind of free response questions. But right now, it's kind of nice, even with our kind of early nascent knowledge of what a derivative is, to talk about how to find derivatives on the calculator. So right here, they all have math print. So we're going to do most of our, well, probably all of our calculations from the home screen. There are ways to do things from the graphing screen. But if you want to evaluate a derivative of a function from the home screen, you're going to hit Math 8. That's the easier way to do it. Okay, if you hit Math 8, notice number 8, if you scroll down, it takes a while to get there. But trust me that it's there. Math 8 says NDeriv. Okay, so if you just hit Math 8, it automatically comes up. That's one way to do it. You could also do it from the shortcut menu if you hit Alpha window, I believe. Yeah, Alpha window has a menu there. Mine is number 3. So I guess it's just as many keystrokes, right? Well, no, it's 2. It's one more. Alpha window 3 is 3 keystrokes. Math 8 is 2. So, over the length of a year, you could save quite a bit of energy using Math 8 instead of Alpha window 3. Okay? But whatever you want to do, it sends up the same thing. NDeriv gives you in math print the Leibniz form of the derivative. Okay? So here's how we would read this on the right-hand side. The derivative at C is, we say the derivative with respect to x. That's how we read that. It's the derivative with respect to x, the independent variable, of the function, f of x, and then this is evaluated at x equals c, or when x equals c. Now this f of x could easily go in the numerator, because remember f of x is just a fancy word for what? What letter? Y. So that's really dy dx, the derivative of y with respect to x, evaluated at x equals c. Okay? But f of x is kind of cumbersome, so we typically kick it out of the numerator and off to the side. But it means the same thing. All right, now we're going to be able to graph as well. You could graph a derivative without even finding its equation by doing that Math 8 command in the y equals window. And instead of like plugging in the specific value of x, if you just plug in an x there as a variable, it'll find the derivative for all x in the window, plot the points, and connect the dots. And you can get a picture of the graph of the derivative without even knowing what its equation is, which is kind of cool. So let's do example 1. We want to figure out what f prime of 4 is if f of x is ln of x. So we hit Math 8, and we type in like this. If we want to write it like this, let's do it like this first. On the right side, that's the same as the derivative with respect to x of the natural log of x evaluated at x equals 4. That would say the exact same thing. That's the verb format. The above version is kind of the noun format. Okay? So that's what we type in. So in that first blinking box, we're going to put an x, and then we type in our function natural log of x, and we're going to close that parenthesis because it automatically opens parentheses to group the whole function together. And as soon as you hit x in the bottom, it showed up as an x equals on the bottom of the evaluation bar, and then you type in a 4. And you hit enter, and you report 3 decimals, 2.50. Cool. Now look at your calculator there, 0.25000000052. One of the things we're going to have to learn all year long is when to trust our calculator and how to interpret its answers. You're the boss of the calculator, not the other way around. What do you think your calculator is really trying to tell you? You think it's really that number? Generally, if you see a string of zeros or a string of 9s, your calculator is doing all of its calculations numerically, and it's not hitting the nail right on the head. So you're going to have to maybe interpret that as rounding down if you see a string of zeros, or rounding up if you see a string of 9s. And how many zeros would it take to convince you that it's trying to make it a terminating decimal? I don't know, 3 or 4. I would say 4. Or 3 zeros and maybe the next one's a 1 or something like that. So I'm guessing that this answer is 0.25 or just 1/4. And it actually is a 4th. Okay? We're going to learn how to find the derivative of the natural log later on, and then we'll plug it in, and you'll see it is a 4th. Okay? So the calculator didn't give us quite the right answer, but it's enough to interpret it correctly. Okay, now let's see what we just found. On the graph of the natural log, this is the last thing to do before lunch. There it is. Here is, we're evaluating at 4, which is right here. And we just found the slope of that tangent line to be a fourth. Is that reasonable? Up 1 over 4, up 1 over 4 at that moment? Yeah. Immediately to the left, the slope's going to be bigger. Immediately to the right, it's going to be smaller. There you go. Calculator, dudes. Have a good lunch.